angle between a line and a plane. So let's say I have a plane here and I have a line which meets this plane at this point. Okay, and this may be in turn intersecting at this point, so it might be going beyond that. Let's say this is B, vector B, which is part of that line, or in other words, the line is parallel to this vector. So line is L, plane is pi, L meets pi at one point. Remember, the line cannot be parallel to pi. Why? Because then there is no angle, unless of course L lies on the plane, in which case the angle would be 0. L, let's say the equation of the line is R is equal to A plus lambda B. Equation of pi is R, vector R dot normal equal to Q. So we require the normal. Let's say this is normal. And remember, normal means that it is going to be perpendicular. Now remember, L, which is the line, is parallel to the vector B, right? Yeah, we know it lies on line itself, but we can say it is parallel to B. So angle between the line and the normal to the plane is, let's say, theta. So this is theta, which means the angle between the line and the plane would be 90 minus theta. Yes, quite straightforward. This is perpendicular, which means 90 degree. So 90 minus theta. Now let us say this angle is phi. So cos theta is equal to, and we know this again, vector n dot vector b by magnitude of normal times magnitude of the vector. Now we know phi is equal to 90 minus theta, which means theta is equal to 90 minus phi, right? So cos theta can be written as cos 90 minus phi. This remains the same. Now cos 90 minus cos pi by 2 minus phi is sin phi. So phi, angle between the line and the plane, would be sine inverse of the vector, the normal to the plane, times dot vector b magnitude of and magnitude of b. So that is the equation of the angle between a line and a plane. Now let's look at the Cartesian form. So let's say L is equal to, remember the Cartesian form of the equation of a line, x minus x1 by L equal to y minus y1 by m, z minus z1 by n. And the equation of the plane is ax plus by plus cz plus d equal to 0. Instead of writing equal to, let's just put. Now the direction ratios of the line are L, M and N. Direction ratios of the normal to the plane, normal to plane A, B and C. We know phi is equal to sine inverse of vector n vector b divided by magnitude of n and magnitude of b. So now let's do the substitutions. Sine inverse of ai plus bj plus ck dot li plus mj plus nk divided by magnitude of n, and that is a square plus b square plus c square times magnitude of b, that is L square plus m square plus n square. Okay, sine inverse of, let's do the dot product, AL plus BM plus Cn by square root of a square plus b square plus c square L square plus m square plus n square. When L is parallel to pi, now this is possible only if AL plus BM plus Cn equal to 0. Then in that case phi will become equal to sine inverse of 0. That means phi is equal to 0. So in case of L being perpendicular to pi, this would be possible only if L by A is equal to m by b is equal to n by c. So which basically means that, let's say this is let's say k. So L is equal to ka, m is equal to bk, n is equal to ck. So which means what this would become is phi is equal to sine inverse of k times a square plus b square plus c square divided by square root of a square plus b square plus c square L square plus m square plus n square. And if we do some cancellations, alright, if we cancel a square plus b square, square root of a square plus b square plus c square in the denominator, in the numerator we will be left with square root of a square plus b square plus c square, and in the denominator square root of L square plus m square plus n square. Now sine inverse of square root of L square plus m square plus n square divided by square root of L square plus m square plus n square. Now why? Suddenly why did that a square, b square, c square become L square, m square, n square? Because k times L square plus m square plus n square square root will be equal to square root of a square plus b square plus c square, since the line is the normal. Since the line is the normal, but the magnitude may differ, so it's going to be multiple, right? So that's why this would be equal to a square b square plus c square, and these two get cancelled, so we are left with sine inverse of 1. So phi is equal to 90 degree. So that is the angle between a line and a plane. That's it. Bye for now.